Welcome to our presentation. We are pleased to share our work on auto-presentation text-to-speech using Azure Cognitive Services, completed as part of IT 434, Cloud Computing.
This project was a collaboration between Shelby Lynch, Jennifer Steen, and Thaddeus Thomas, and we are excited to present our findings to you today. Through this presentation, we aim to provide you with a comprehensive understanding of our project and the insights we have gained from our research.
This presentation will be recorded using Azure text-to-speech capabilities as proof of concept.
The agenda for this presentation includes several key topics that we will be discussing in detail.
First, we will present the problem statement that has led to the development of our solution.
Following that, we will provide an overview of our pricing tiers and the options available to our customers.
We will then delve into the technical aspects of our solution, discussing the standard web/container and how we leverage Azure for our platform.
Additionally, we will touch on network resources used in speech resources, as well as env variables and SSML.
We will provide an overview of our application code and how it can be used in conjunction with our PowerPoint scraper.
Next, we will discuss app creation and provide some conclusions based on our research and development.
Finally, we will touch on future work and provide references for further reading.
We will conclude with a Q&A session to address any questions or concerns.
The School of Technology and Computing faces a language problem in delivering lectures and presentations to its students.
While pre-recorded lectures and presentations can help educators save time and effort, they may not be engaging or interactive enough to capture students' attention and facilitate learning.
Our team proposes a cloud-based text-to-voice process using Microsoft Azure Cognitive Services to solve this problem.
Our project aims to automate converting text from presentations into audio, enabling educators to record and read their presentations and lectures aloud in real time.
This paper describes the project's research, development, and deployment, including the technical tools and approaches.
Our project will immediately benefit the School of Technology and Computing and provide a scalable and cost-effective solution for other organizations facing similar language problems.
One of the first considerations when creating an application, especially in the cloud, is how much it is going to cost.
There are several benefits to using the paid service of the Speech API as opposed to the free service.
Increased limits: the free service has usage limits that can be quickly reached, whereas the paid service offers higher limits on the number of requests, characters, and other parameters.
Improved quality: the paid service offers improved accuracy and speed compared to the free service, with better recognition of accents, languages, and specific domains.
Customization options: the paid service provides greater customization options, such as the ability to create custom speech models, custom vocabularies, and acoustic models. Technical support: the paid service comes with technical support, including documentation, troubleshooting, and assistance from Microsoft engineers.
Compliance and security: the paid service offers compliance and security features that ensure data protection, privacy, and regulatory compliance, including HIPAA and GDPR.
An important thing to note is that we used the free tier for our application, which limits the extent of what this application can do. However, with our project being a proof of concept and not a full-blown production application, it was quite sufficient to meet the end goal.
In summary, while the free tier of the Speech API can be sufficient for small-scale projects, the paid service offers benefits such as increased limits, improved quality, customization options, technical support, and compliance and security features that are essential for larger and more complex applications.
It's important to carefully consider the needs and budget of the project when deciding which service to use.
Speech to text: standard is $1 per audio hour, custom is $1.40 per audio hour, with additional endpoint hosting cost of $0.0538 per model per hour. Enhanced features such as language identification and batch diarization for 3+ speakers cost 30 cents per audio hour per feature. Conversation transcription multi-channel audio is $2.10 per audio hour. Text-to-speech, neural real-time synthesis is $16 per 1M characters, long audio creation is $100 per 1M characters. Custom neural training costs $52 per compute hour, up to $4,992 per training. Real-time synthesis costs $24 per 1M characters, and endpoint hosting costs $4.04 per model per hour. Speech translation, standard is $2.50 per audio hour. Speaker recognition, speaker verification and identification costs are not provided. Voice profile storage, the cost is not provided, but 10,000 free voice profiles are available per month.
This slide details the requirements for.
Log into the Azure portal and go to the Cognitive Services page.
Select the speech service and create a new speech resource by providing a name, subscription, resource group, and location.
Configure the speech resource settings, including the type of service, speech-to-text, text-to-speech, speech translation, language and acoustic model, endpoint URL, and authentication key.
Test the speech service using the Azure portal or a code sample.
Integrate the speech service into your application using the Azure SDK or REST API.
An important consideration when creating a speech resource is to properly secure the resource to prevent intrusion.
These steps provide a general overview of the process to create resources for cognitive speech services on Microsoft Azure, but the specific details may vary depending on the specific use case and requirements.
Showing how to create an environment variable for a speech resource and connecting to Azure Cognitive Speech Services in the cloud is important for a few reasons.
Security, storing the Azure subscription key and endpoint URL in an environment variable is a more secure method than hard coding them into the code. This makes it more difficult for unauthorized users to access your credentials.
Reusability, using environment variables, you can reuse the code for multiple applications without modifying the code each time. This makes it easier to maintain and update your code in the future.
Scalability, when deploying applications to the cloud, you may need to scale them up or down depending on the demand. By using environment variables, you can easily change the settings for your speech resource without modifying the code, saving you time and effort.
Best practice: storing sensitive information such as Azure subscription keys and endpoint URLs as environment variables is a best practice in software development. It ensures that your code is secure, maintainable, and scalable.
Overall, showing how to create an environment variable for a speech resource and connecting to Azure Cognitive Speech Services in the cloud is an important step in developing a secure, maintainable, and scalable application.
If you want to use the Azure Cognitive Services Speech API, you must first set up an environment variable for your API key and region. This is important because it allows you to access the API securely and ensures that your requests are routed to the correct region. The specific command to set the environment variable will depend on your operating system.
Once you have set the environment variable, you must run a command to make the changes effective. This will ensure that your API key and region are recognized and used when you make requests to the Speech API.
Microsoft Learn offers a quick start guide for using the Speech API, which is a great resource for getting started. Additionally, they provide SDKs for several programming languages, including Python. These SDKs can help you quickly integrate the Speech API into your application and provide code samples and documentation to help you get started.
Finally, when setting the environment variable for your speech resource region, it's important to set the speech_region variable to the region of your resource. For example, if your speech resource is located in the Westus region, you would set the speech_region variable to Westus. This ensures that your requests are properly routed to the correct speech resource.
The documentation for the speech service provides a wealth of information on how to use and customize the service to meet your application's needs.
The documentation covers getting started, authentication, speech-to-text, text-to-speech, speech translation, and customization.
The documentation includes code samples and tutorials in several programming languages, including C#, Python, Java, and Node.js.
The documentation also includes guides for integrating the speech service into popular development environments and frameworks, such as Visual Studio and Azure Functions.
When using the speech service documentation, it is important to carefully read the instructions and examples to ensure you use the service correctly and efficiently. If you have questions or issues while using the speech service, Microsoft offers support options such as community forums and technical support. You can also submit feedback on the documentation to help improve it for future users.
By utilizing the speech service documentation, you can save time and effort in developing your application by leveraging Microsoft's best practices, tools, and resources. This slide shows the Speech Studio hosted on Azure and the flowchart for audio creation utilizing the Speech Studio.
Define the input text structure that determines the structure, content, and other characteristics of the text-to-speech output. For example, you can use SSML to define a paragraph, a sentence, a break or a pause, or silence. You can wrap text with event tags such as bookmark or viceme that can be processed later by your application.
Choose the voice, language, name, style, and role. You can use multiple voices in a single SSML document. Adjust the emphasis, speaking rate, pitch, and volume. You can also use SSML to insert pre-recorded audio, such as a sound effect or a musical note. Control pronunciation of the output audio. For example, you can use SSML with phonemes and a custom lexicon to improve pronunciation. You can also use SSML to define how a word or mathematical expression is pronounced.
Utils.py. It contains a function to load speech credentials from Azure. Load speech key and region from environment variables.
Speech_utils.py. Imports the speech SDK and load_credentials function from utils.py. Defines a constant voice and a function to initialize the speech config with the loaded credentials. Defines a function to synthesize text to audio using the speech synthesizer. Subscribes to events that can occur during the speech synthesis process. Handles error checking and result checking.
Main.py. Imports necessary functions and constants from speech_utils.py. Defines an SSML string that specifies the text to synthesize and the voice to use. Initializes the speech config and synthesizes the SSML text to audio. Saves the output to an audio file. Creating an executable using PyInstaller so we can distribute this program to multiple platforms.
1. Install PyInstaller. Start by installing PyInstaller, either using pip or by downloading the source code and running the setup.py file.
2. Create a Python script. Write the code for your application in a Python script. Make sure that all required packages and dependencies are imported at the beginning of the script.
3. Test the script. Test the script to ensure that it runs without errors.
4. Create a spec file. Use PyInstaller to create a spec file for your application. The spec file contains the configuration options for PyInstaller to build the executable, such as the name of the script and any additional files or packages that should be included.
5. Edit the spec file, if necessary. If needed, edit the spec file to include any additional options or settings for PyInstaller.
6. Build the executable. Use PyInstaller to build the executable by running the following command in your terminal or command prompt: pyinstaller, options, scriptname.py. Replace scriptname.py with the name of your Python script.
7. Test the executable. Test the executable to ensure that it runs properly and includes all necessary files and dependencies.
Distribute the executable. Once you have tested the executable and verified that it works properly, you can distribute it to users.
Here we have a demonstration of the creation of the audio files using the scraped text from before. Hopefully everything is working properly because a lot of strange things have been happening ever since this program started. Probably just coincidence though. Text-to-speech can improve accessibility, remove language barriers, reach a global audience, aid in early learning, help the visually impaired, and enhance understanding of presented content.
With more products of text-to-speech applications like ours available on the market, the end users will have more opportunities to find an automated solution like the one created for this project.
In conclusion, text-to-speech technology has proven to be a powerful tool for enhancing accessibility, communication, and education. With the increasing availability of text-to-speech products like ours, we can create a more inclusive and connected world for all. An application beyond this project's scope was to create a complete application from speech input to output. This application would take speech from the user or a file and then answer questions. It would be a chatbot that could interface with multiple resources to provide a menu of dynamic content.
This would be using instantaneous voice-to-text creation, so a further reduction in steps with an increase in price.
Interface with multiple resources for dynamic content.
Add spell checker using API integration.
Here is a list of references that we used for this project.
Any questions?